Our topic is ideal gas, macroscopic concepts and gas laws. First of all, I will define what's an ideal gas. I define ideal gas by saying it is the gas which obeys gas equation PV is equal to nRT at all temperatures and pressures, where P is pressure of the gas, V is volume of the gas, N is number of moles of the gas, R is molar gas constant, and T is the temperature of the gas, in kelvins. So I will say a gas which obeys equation PV is equal to nRT, which I will describe later on. This is an ideal gas equation which obeys the equation PV is equal to nRT at all temperatures and pressures. Then that would be the ideal gas. Clearly, there's no ideal gas which exists in this world, because when the pressure increases at suppose the pressure is increased, then volume gets on decreasing. Ultimately, it still reaches where a gas is liquefied and there cannot be a zero volume of the gas. So of course, at these real gases at very high pressures, they do not obey this equation. And similar is the case for the real gases. When the temperature decreases, and suppose when it reaches to 0 Kelvin, the volume of the gas becomes also zero. And although this equation is satisfied for the ideal gases, because if T is equal to 0, we will be 0 for ideal gases. But since there is no ideal gas in this world, all these real gases, they deviate from ideal gas laws at very low temperature and very high pressure. So whenever we say, sometimes you can also write the basic assumptions of kinetic molecular theory of gases 2 or 3 in order to explain the ideal gases. But this is also the definition accepted by the examiners. Now that's the ideal gas. Then comes the macroscopic concepts. Actually, there are the 4 macroscopic concepts. Those are, I will say, 4 macroscopic concepts. Macroscopic concepts are those concepts which explains the behavior of the gas in a bulk way, or in a bulk quantity, or as a whole. They describe the state of the gas or condition of the gas, and that's why known as macroscopic concepts. We will also study microscopic concepts by studying the internal energy of the gas, but this is the macroscopic concepts. Macroscopic concepts are 4. First is pressure of the gas. Pressure of the gas is known as macroscopic concept. Volume of the gas, temperature of the gas. Temperature of the gas is macroscopic concepts, and of course mass of the gas. So these are the 4 macroscopic concepts. When we say what are the macroscopic concepts of the gases, we say pressure of the gas, volume of the gas, temperature of the gas, and mass of the gas. So these are the 4 macroscopic concepts. First, I define the ideal gas equation. Ideal gas is that gas which obeys the equation PV is equal to nRT at all temperatures and pressures. Then macroscopic concept, the pressure of the gas, volume of the gas, temperature of the gas, mass of the gas are known as macroscopic concepts. Now what is the gas law? Actually, gas law, we say gas law, I can define gas law. It is the relationship between any 2 macroscopic concepts and keeping others to others two as constant. So for example, when I say I state the Boyle's law. Boyle's law, what does the Boyle's law say? That Boyle's law tells us the volume of given mass of a gas is inversely proportional to pressure, provided temperature is constant. Temperature is constant, and of course the mass is also constant. Why mass, temperature, mass both are constant? Why? Because it is usually says given volume of a gas. When you say given volume of a gas, means mass is constant. Given volume of given mass of a gas, then mass is constant. Volume of given mass of a gas is inversely proportional to pressure of the gas if temperature is constant. So when we say volume of given mass of a gas, means we are taking mass of the gas as constant and temperature is constant. So this relationship between volume and pressure, and that is the one gas law. Actually, there can be at the most 6 gas laws, not more than 6 gas laws. How? See, suppose I have this pressure, volume, mass, temperature. So first I have a pressure and volume relationship, which is known as the Boyle's law. Then there's the pressure and mass relationship. Of course, greater the number of molecules or moles, greater the pressure. And of course, third is the pressure and temperature. Greater the pressure, greater the temperature. Then fourth one is volume and mass. Then fifth one is volume and temperature, and sixth one is mass and temperature. These are the 6 gas laws, because these are the only relations which are possible for these macroscopic concepts. So in this lecture we describe first the ideal gas. Ideal gas is that gas which obeys the equation PV is equal to nRT, and no ideal gas exists in this world. P is the pressure, V is the volume, N is the number of moles, R is molar gas constant, T is the temperature. And then we define the macroscopic concepts. Macroscopic concepts are 4: pressure of the gas, volume of the gas, mass of the gas, and temperature of the gas, because they describe the overall behavior of a gas, and that's why they're known as macroscopic concepts. And gas laws, a gas law is a relationship between any 2 macroscopic concepts, keeping other 2 as constant. So there are 6 gas laws I have described in that way, because the pressure may have the relation to the volume, mass, and temperature. Then volume may have the relation to mass and temperature. Then mass will have a relation to temperature. So these all are the 6 gas laws which are possible.